Hello everyone and welcome to my channel Octopus Math by Sahiba. We are going to solve this paper, Cambridge IGCSE. This is paper 3, February-March 2016, and this is the second variant of paper 3 core. We are trying to solve this. I also have my marking key over here so we can actually tally the answers at the same time. So question number 1 is, Whisper is a horse. And let me tell you one thing, we are allowed to use electronic calculators. So I have one here. We will use this if needed. Okay, so moving on to question number 1. Let me turn on my pen. Whisper is a horse. Part A, Whisper eats 3 apples every day. Work out how many apples she eats in 52 weeks. So first we need to see that this is in days and this is in weeks. So first we need to have these in common. So we either convert this into weeks or this into days. So I think weeks to days is easier because 1 week is 7 days. We don't want to go in fractions and decimals. So weeks to days are easier. So 1 week is 7 days, right? And we are interested in 52 weeks is how many days. So basically what we do is we cross multiply them, and 1 times x is x and 7 times 52 is 364. So basically there are 364 days we are interested in. Okay, now the question is that Whisper eats 3 apples every day. So this is again a rate or a question of rate, that he eats 3 apples every day, means 3 apples in 1 day, right? And we are interested in 364 days, so we are going to write 364 here, days under days. And then this is unknown, so again cross multiply, because the more when the days will increase, the amount of apples he would eat will also be greater than 3, right? So x, no, I let's call it another variable because we have already taken x here. So y times 1 is y, and 3 times 364 will be our answer, and that is 1092. Yeah, 1092 it is. Okay. Part B, Whisper is exercised twice a day. The first time is for 30 minutes and the second time is for 1.5 hours. That means it's for 90 minutes. You can either convert this into hours or this into minutes, whatever it is feasible, right? Write down the fraction of the day that Whisper is exercised. Okay, so first we need to find out how many the total time he exercised per day. Okay, so first time is 30 minutes. If we want to convert everything into minutes, then we have to divide it by the total minutes in an hour, in a day, right? So what do we do is, I think hours is better because we know 24 hours, there are 24 hours in a day. So yeah, 30 minutes is also an easy calculation. It's 0.5 hour, and 1.5 is basically 1.5 hours, right? So together they are 2 hours. So basically he works for, he works out for 2 hours. It's going to be 2 out of 24 because there are 2 hours out of 24 hours he spends in exercising, right? So it's going to be 1 over 12. 1 over 12, okay, fine. Right, because it says in simplest form, so 2 out of 24 will not be acceptable, right? You will still get a mark, but you won't get full marks. It's 2 marks. Okay, write down the fraction of a day that she is not being exercised. Okay, so if it's 1 out of 12 that she's exercising, so that means there are 11 out of 12, 11 parts out of the whole 12 hours that she's not exercising, right? You can also do it the other way, that 24 minus 2, because she's exercising 2 hours in the whole 24 hours. So 22 is left. I mean, 22 hours are left that she's not exercising, and then you divide it by 24 to get the fraction, and then you simplify. But that's okay. You can still write it as this, that if 1 out of 12 is the time that she is the fraction for the time she did exercise, so 11 out of 12 will be the time that she did not exercise, right? Okay, so 11 out of 12 is again correct. Okay, part C. Whisper weighs 429 kilograms, correct to the nearest kilogram. Complete the statement about her weight. Okay, so correct to the nearest kilogram, which means to the nearest unit, right? To the nearest unit means that we're talking about 1 divided by 2. This is actually a question for limits of accuracy. So we're talking about the nearest kilogram, which means we are talking about the unit, divided by 2, which means it's zero point 0.5, right? So this 429 is actually correct to the nearest kilogram, means there is a slight error from like 428.5 and 429.5. Okay, it could be somewhere in middle. It cannot be exactly 429.5, because if it was 429.5 exactly, then I mean the first decimal place after the decimal would be, if it was 5, then it would round it off to 430. So we don't want the number to be, the first decimal to be zero point 0.5 after 429. It can be less than 429.5, or it can be 428.5 or greater than that, right? Because if it was 428.5 to be exact, then it would still round it off to 429. So our answer is 428.5 to 429.5. Notice the signs that this is exclusive and this is inclusive, right? So 428.5 and 429.5. We're done. Question number 2. Describe fully the single transformation that maps A onto shape B. Okay, so this is basically where I'm trying to also explain you how things are. So in transformation, we have 4 categories. One is translation, one is reflection, one is rotation, and the last one is uh, enlargement, right? We can definitely see that this is not translation, because in translation what happens is that the shape actually shifts size. Like if you see A and D, basically D is the enlargement, but if you see that, kind of, if it was the same size as A, then you can say that this A and D, D is the translation of A. Okay, right? So because D is not the same size as A, that's why it's enlargement. But I was just giving an example of how, what translation is. Reflection is, you can say that A and C are reflections of each other. Like it's exact same, but there's a line in between on which A has reflected onto C, right? So B is definitely rotation. It's not enlargement, because it's the same size. It's not reflection. It's not translation, which means definitely it's rotation. So even if you, this is 3 marks, which means there are 3 reasons, right? I mean, there are 3 pointers to be written. So rotation, if you could not understand anything else, just rotation, you will still get 1 mark, right? So rotation for 1 mark, and then we need to see what degrees of rotation and what's the center of rotation. So this, I think, is 180-degree rotation, because it's if you rotate it here, like um, if it was 90-degree, one rotation, it will be somewhere here, right? The shape B will be somewhere here. If it was 90-degree anti-clockwise, the shape B will be somewhere here, but it's taken another turn, so I think it's rotation of 180 degrees. Clockwise, anti-clockwise doesn't really matter, because 180 degrees is fine. If you still want to write clockwise, anti-clockwise, I think it's okay. You can write, but writing clockwise, anti-clockwise would in 180 degrees still it doesn't matter. Okay. And then we need to write the rotation, point of rotation. How do we find out the point of rotation? Is that we mark any two corresponding points. Like for example, this is one point and the corresponding point will be this. All right. We have to find the matching points. So one is this point. I'm going to connect it roughly. This is going to be rough. Okay. And then I'm going to find another corresponding point. It could be these 2 points. It could be these 2 points, whichever you want. Okay. So let's take these 2 points. Now you need to connect these. Okay, and then with these two lines you have to draw perpendicular bisectors to see where these two perpendicular bisectors meet, right? So I'm going to draw a rough perpendicular bisector, right? You put your compass needle here, make an arc. You put your compass needle on the same point, make an arc down. Shift the needle, put it here, make an arc up, make an arc down, right? Okay, connect these two. This is so rough. Okay, you will tally it from the marking scheme. Okay, and then again from the second, put your needle on this first point, make an arc here, make an arc down, put the needle on the second point, make an arc up, make an arc down, and then you connect these two, right? And the point they are going to meet will be your point of rotation, right? So roughly this is about 6 7. This is roughly about 6 7 because my arcs are not accurate. The answer must be around it. All right. So I'm pretty sure that you if you made your arcs and lines accurately, you'll be able to uh, point the correct thing. So the answer is 6 7. Oh wow, wonderful. 6 7. So this is roughly 6 7. Yeah. Okay. So the point of rotation is, you can write the whole thing. I'm just writing the short form, point of rotation. Okay. So changing the color back. Shape C from A to C. Okay, so from A to C we've already noticed. Let me erase this. Right. So from A to C we've already noticed that it's reflection. And if you want to see what's the point, I mean what's the line of reflection, you can see that if, you connect two corresponding points and then you try to find the midpoint of the two corresponding points. Okay. uh, Here it's so obvious that it's going to be this line only, right? That's how we do it. You don't actually have to do this. I mean, if the questions are complicated then you can, but I think the reflection questions are pretty easy. You can easily see the line of reflection, right? So this line is going to be the line of reflection. So this line will be the line of reflection, and the coordinate, I mean the equation of this line will be x is equal to 1. So basically it should be of 2 marks. Shape C, yeah. So 2 marks. 1 mark is for defining what type of transformation it is. So this is reflection. And the second mark is for the line of equation. So you will say that equation of lines. So you'll say reflection along the line x is equal to 1, right? Okay, so from A to D, yeah, A to D is enlargement, right? A to D is definitely enlargement because A and D, they have changed size, right? And this is positive enlargement because D looks somewhat like it has translated. Okay, so if you think that it has translated and not rotated at the same time, so it's positive enlargement. Otherwise, if you think that it has rotated as well, so this is called negative enlargement. We'll see in the other video how this goes. Anyway, so A and D, D is the enlargement of A, and first of all we'll see the center of enlargement and then the enlargement factor, the scale factor, right? So just notice that these are 3 blocks and these are 1, 2, 3, 4, 5, 6 blocks, right? So this is a multiplier of 2, positive 2, because they have only, it looks like it has translated, right? So it's positive 2. So scale factor is 2, right? And then you will have to say that this is enlargement, 3 marks. So one mark for the for identifying this as enlargement, the second mark for the scale factor, and third mark for the center of enlargement. All right. And how do we calculate the center of enlargement? We connect corresponding points. Like for example, I'm going to connect these 2 points. These two are corresponding, right? And any other 2 points, like for example these 2 points, right? Let me connect them. And where the points that these two lines intersect, that's going to be our point of enlargement, right? So because they don't intersect somewhere within this area, so I'm going to extend the lines and then see where these are going to meet. My lines are not straight. So this is roughly my point. This is 6, 10. All right. So the center of enlargement, again, short form, is 610, right? Let's check the answers. Reflection in the x is equal to 1, scale factor of 2, 6, 11, right? Okay, on the grid, draw the image of shape A after a translation by the vector -3 and 2. Okay, -3 and 2, all right. Okay, so basically you have to transform A, uh, like translate this figure A to this, right? So this -3 it describes the translation on the x-axis, and this 2 describes the translation on the y-axis. So you pick a point. So we are talking about to translate this shape. There are 1, 2, 3, 4, 5, 6 points on this on the figure A. Pick a point, pick a random point. Let's say this point we need to translate first. So it has to go 3 units on the negative x-axis. That this negative does not mean that the -3 on the x-axis. It means 3 units to the left. Okay, from this point you need to go 3 units to the left. If it was +3, we need to go 3 units to the right. It says -3, which means it's 3 units to the left because we are talking about the x-axis. So 1, 2, 3. Now it has moved -3 units on the x-axis now, and do not forget about this too. So this tells you that 2 units on +2 on the y-axis. That means it's not talking about this +2 on the y-axis. Basically means that you need to go up by 2 units, right? So this is 1 and that's 2. So this is my new point. I mean, this point is translated up to there. So 3 units to the left and 2 units up. Similarly, you will transform each of them. You can transform any like 2 to 3, and then you create the shape, because the shape will remain the same. It's only that shifted the position, right? So 1 point will be enough. So this will be my second point, judging its size, and then 2 units, 2 blocks down will be my this point, right? And this is 2 blocks away, so it's going to be this, right? So correct translation, right? Okay. So that for this you'll have to trust me that I've done it correct. Okay. Question number 3. 10 students each take 2 French tests. Their marks are recorded in the table below. Okay, one of the 10 students is chosen at random. Find the probability that their mark on test 2 is higher than their mark on test 1. Okay, so first we need to see how many cases qualify on this, that their marks on the test 2 is higher than the marks on test 1. So let's just mark it, okay? So this wouldn't qualify. Test 2 is not higher. Test 2 is not higher, not higher, not higher. Yeah, okay. So this is one thing where the test 2 scores are higher than test 1. This is another thing. No, this wouldn't qualify. This would not. This would not. Okay, this would not. So I think there are two students out of 10, right? So you can write 2 out of 10 or 1 out of 5 is also a great thing to write. Let's check the answer. 2 out of 10 or equivalent, right? So we are good. Right. We need to do the scatter plot complete. Okay, scatter diagram. Okay, so for part B1, complete the scatter diagram. The first 6 points have been plotted for you. Okay, so these were A, B, C, D, E, F, which have been already highlighted. They've been plotted. So we need to mark or plot these only. Right, so 38 and 37. So 38 on the test 1, which means on the x-axis they have test 1. So 38 is here, right? Because it's 5 boxes and 10 units. So 38 is this point, and then 38 to 37, right? So this is going to be 38 again, because it's again 5 blocks and 10 units. So this is 36, and in between this 37. So I'm going to put a mark here and then put a cross accordingly. Right. 80 and 72. So this is 80, a pretty good number. And then 72. So 72 will be here. First, let me put a mark so it's easier to see, and then I'm going to put a cross, right? All right, 192. 100 is a very good number, and then 92 will be 1 block ahead of 90. 1 block is 2 units. So this is 192, and then we have 57 and 54. So 57, this is 58, this is 56, so 57 will be right here in the middle. Okay, and then we have 54. So this 2 blocks away, up from 50, ahead of 50. So this should be somewhere here. Okay, let me just try to plot it nicer. Okay. 4 points correctly plotted, right? So I think we've got the marks. Right. Let's move on. What type of correlation? So I think the correlation, because it's going up, I mean the gradient of the line will be positive. So it's positive correlation. You can also say it's strong positive correlation, but just writing positive correlation is also fine. So I would prefer to write strong positive, because all the points are, almost aligned. So you say it's strong positive. I like to call it strong positive. You can also write only write positive if you want. So it says positive. So I think we've got the mark. All right. On the line, draw the line of best fit, that too without a ruler. Oh my God. Okay. So what do? Is that we don't have to start from the origin. Okay? We don't actually have to try to connect our best fit line from the origin. We just have to see that to draw a line that is let me zoom it a bit. We don't have to really connect the points. We have to just draw the line of best fit. That means we have to draw a line that um you know that's aligned with the best fit line. Doesn't look very best. Okay, so draw the best fit line. Okay, I think you will still get mark on it. Correct ruled line. All right. So part 4, another student scored a 45 on test 2. Use your best fit line to estimate. Right. All the answers will be estimated, because you cannot really see if, I mean, the answers would definitely be estimated, because it doesn't guarantee you if you got 45 marks on test 2, you will get the, comparatively the same mark you got on the graph. It doesn't guarantee you that you will get the same mark on test 1. It will be all estimated. You will just get an idea. So according to my best fit line, which is not actually straight, it's supposed to be a little more straight or whatever. This is just an estimate, because the lines is not straight. 45 on the test 2 will somewhere estimate us. Let's take this point, and this point is somewhere around this, which has to be 47, 48 roughly. So roughly I'm going to write here 47 maybe, right? Let's check the marking scheme. 46 to 48, yeah, 47 is fine. Okay. Part 5. A student scored 10 marks on test 1. Explain why you should not use scatter diagram to estimate. Okay, fine. Yeah, so the marks are from this range. The smallest is 31, I could see, and the greatest is 100. You can definitely not, you don't have 10 in the range, so you cannot never predict. So you can say that 10 is not on the list. List of what? Uh, List of test 1 marks, right? So you can say that. The answer is 10 is not in range of recorded test 1 results. Yeah, it's the same thing. Okay, so it doesn't come in the range. I think instead of list, range is better because I said it, but I did not write it. I'm sorry. So range is better, yeah. Question 4. A farmer has 45 horses and 20 cows. Write this as a ratio horses to cows. So 45 and 20, you can divide them one by one, or you can also take the HCF of them, right? So 5 divides both 9 and 4, and because 9 and 4 are not further divisible by one common number, so that means it's 5 which is divisible by both. So 49 changed to 9 and 20 changed to 4. So it's going to be 9 is to 4, right? Question 4, the answer 9 is to 4. Yeah, we're right. Okay. The farmer wants the ratio horses to cows equal to 5 is to 3. He keeps 45 horses but buys some more cows. Okay. So 45 are the number of horses. I'm writing it here, and this is the number of cows. The new ratio we don't know, right? So let's call it X. The new, I mean, the number of cows we don't know exactly. We call it as it is. Now the new ratio he wants for horses to cows is 5 is to 3. So for horses the ratio is 5, and for cows the ratio is 3. You can do it by cross multiplication. You can do it by making the ratio same, like 5 times 9 is 45, so 3 times 9 will give you this number, or you can simply do it by cross multiplication. 3 times 45 will give you 5 times x, and then x is 3 times 45 divided by 5, so which is 3 times 9. 27 are the cows. 45, I mean the number of horses and cows have to be 45 and 27 in order to give the ratio to 5 is to 3. But how many more cows? So he already had 20 cows, so I think he needs to buy 7 more cows, right? Yeah, okay, so 7. 3 years ago, the farmer invested, okay, this is the calculator question, right? So this is the principal amount which is invested. This is the rate and compound interest, all right. After 3 years compounded, and I mean the 3 years, okay, right. The formula is amount. This is the total amount compounded, I mean at the end, like with this amount basically includes the principal amount and the interest amount. So the formula is times, this is n is the number of times it has compounded over the period, right? It's not necessarily 3 all the times, but it will be 3 in this case because they have the amount has compounded 3 times in 3 years. So basically n is the number of times it has compounded, right? If it compounded every 6 months in 3 years, so n will be 6, right? I mean semi-annually. So that means it compounded 6 times in 3 years. So n will be 6. So right now n is 3 only because it compounded, the amount compounded once a year. Right. So principal is 3750. 1 plus rate is 4 divided by 100 is 0.04 power n. Right. Let me quickly use the calculator. 3750 times 0.04 powered 3, right? So it's going to be, sorry, the amount is 4218, and that's the total value of its investment. So 4218.24, or if you want to round it off to three significant figures, you can write it as 4220, right? You can say that. But let's see the answer. 4218.24. Yeah, okay, correct answer only. So, okay, this is fine. Let's obsolete this. All right. Part 2 says the farmer wants to wants to spend his investment on buying goats. Goats cost 126 each. Okay, so it basically talks about this investment. So you can do it orally, that you divided by the dollars, I mean 126. But for all those students who actually struggle in deciding where to multiply the two numbers and when to divide the two numbers, I'm going to give you a quick short way. Like for example, one goat costs you $126, right? That's for one goat. So how many goats can you buy? So you don't know the number of goats, you write X here because the count is missing. And then the total cost is 4218.24. So because that's dollars, right? And then you cross multiply because the more goats you buy, the more bill you'll have to pay. So 4218.24 times 1 is the same as 4218.24 is equal to X times 126. And when you divide this whole thing by 126, you would get 4218.24 divided by 126. Right, so this gives you 33 point, let's say 5. And definitely you cannot buy 33.5 goats. You cannot buy a half a goat, right? That means this actually means you always have to round it out backwards, that you were able to buy 33 goats, and then for the 34th goat you are short of money, right? So how much money is left, things like that. So first we need to see how much 33 goats will cost you. So 33 goats, 126 per goat is 4158, and you have 4218.24, and 4158 is the amount that you will be spending on 33 goats, right? I'm not sure. 14158, yeah, okay. So 4218.42 minus 4158, that gives us $60.42. All right. So it's 33. Did I write 42? I'm sorry, it's just 24. Right. Part C, the farmer grows carrots in 2014. The selling price was, okay. So again, 2014, this is rate. So in 2014, the amount was 96 per ton. And in 2015, the amount is increased by 18%, right? Work out the increase in the selling price from 2014 to 2015. So the increment is 18%. So basically we need to calculate 18% of $96, which is 17.28. The farmer has 20 sheep, each has 0, 1, 2 or 3 lambs. The table shows the information. Calculate the mean. Okay. So for mean, we need to see how many total sheep are there. So it's 1 plus 4 plus 12 plus 3. It's already given, but you can still verify. It's going to be 20. And then for mean, you need to calculate f of x. And what is f of x? This is f and this is x. So you first need to multiply them. So this is 1, 4, 24 and 9 together. When you add them all up, you will get 37. And the mean is summation of fx divided by summation of f, which is 37 divided by 20. 1.85 it is. Okay. Part 2, the farmer takes one lamb away from each of the sheep with three lambs. These lambs are given to three of the four sheep. Okay, that's a little complicated. Um, so part 2 a little complicated to explain, but I'll still try to explain you. So explaining this to you in a very, like, I'm calling out sheep by numbers. Okay, so this sheep 1, this sheep 2, sheep 3. Unfortunately, I have to write it up to 20 because I need to be more efficient in explaining how this is done. And then you can yourself um, see if you find out a shorter method. Let me know also. So it says one sheep has no lambs, which means this one has zero number of lambs. And then it says there are four sheep that have one lamb each. So which means these four probably will have one lamb each. And then there are 12 with 2, so 3 is easier. Let's say that these 3 have 3 lambs each and the remaining have 2 lambs each, right? So what the question is that the farmer takes one lamb away from each of the three sheep with three lambs. Now, so these are talking about these lambs, that the sheep which have three lambs each, one is taken away from each of these three. So which means now they have two each, right? One is taken away. So which means this has two, this has two, this has two. So notice that the category of two has increased. Right now, when we've just taken away their lambs, you will see that there is an increment in the uh, count of sheep that have two. So they have increased to 15, like three more. Okay, and then what happened to those lambs? They have been given to each they have been given to three of the four sheep that have one lamb. Okay, so these are 1, 2, 3, 4. These are four sheep that have one lamb each. So they've been, all these three lambs that have been taken away from these three, they've been given to three of them, which means S2 now have, like sheep 2 now, first it had one, now it had one more. So let's say it got 2, S3 is has have got 2. Like previously it had 1 and one more is given to it. So 2 it has right now. S4 also has 2, and let's say that S5, like sheep 5, is the fourth sheep which had previously one lamb, and he's not been given a lamb, an extra lamb, because it says there is only 3 of the 4 sheep that have been given. So maybe this is the unfortunate sheep that did not get the lamb, right? So now let's try to count how many sheep are there with the number of lambs. So again, there's one sheep only with zero number of lambs, so one is I think okay. And now we notice that there are no sheep with three number of lambs, so this will go to convert to 0. Now how many sheep are with one lamb? So previously it had 4, but now these 3 have got one extra one, so there's only one sheep which is left with one lamb. And now we're talking about the number of sheep that have 2 lambs. So previously it was 12, and now there are 3 more added here and 3 more added here. So 6. That turned out that it's 18. right? So let's try to complete the table. 1, 1, 18 and 0. 1, 1, 18 and 0, right? All right, explain why the mean number of lambs per sheep does not change. Okay, the mean number of lambs I don't think would change because uh, the number of lambs and the number of sheep is still the same. So I don't think it would change because it's only transformed from one category to another. It's the same number of lambs, same number of sheep, right? So yeah, same total number of, yeah, it's the same thing. Same number of lambs and same number of sheep. So that's why it wouldn't change the mean. What does the prism tell you about the solid in the diagram? It tells us many things. You can say that the cross section is the right triangle ABC. You can say that the prism is uniformly divided into cross sections from A to E. You can call it, I mean, you can explain it any way you want. So I think talking about cross sections should be the ideal thing in this. Let's see what the marking scheme says. Constant cross sectional area, yeah, that's what the prism is, yeah. So we'll take that. Okay, show that AB is 3. So AB is 3 by Pythagoras theorem. AC squared is equal to AB squared plus BC squared. So AC is 5 squared, is AB is unknown, and BC is 4. So 25 minus 16 is 9 and x is 3. So we have shown it. Calculate the volume of the prism, give the units of your answer. Okay, so volume is base area into height, and base is this cross section, right? So the volume will be base area times height. Height is not the height of the triangle but height of the prism. So base area is the height of the triangle ABC. So area of the triangle will be half into base into height. So base is 4 and height we just calculated it to be 3. And the height of the prism is this 7. So 2, 3, 6 and 6 sevens are 42. And the centimeter square, it has centimeter cube, it has to be because it's volume, right? Let's check the answers. Square root of 9, 42 centimeter cubed, right? D on the 1 centimeter square grid, complete the net of the prism. Two faces have been drawn for you. So let's quickly check that this is 1, 2, 3, 4, 5, 6, 7. So this is 7 centimeter, and this is 3 centimeter, and this is 5 centimeter. So let's take a look at what shapes, I mean, what faces have been drawn. So one rectangle is 3 by 7 and the other rectangle is 5 by 7. The first rectangle was 3 by 7. So 3 by 7, AB was 3, right? And then this is 7. So, I mean, DC is 7. So BF is also going to be 7. So when they're talking about 3 by 7, they're talking about the rectangle ABFE. And the other rectangle which was drawn was 5 by 7, and that is the rectangle A, uh, A, E, D, and C, right? This is the whole rectangle A, E, D, C. This is the whole rectangle that they are talking about for the second one, right? So Now there are, if you notice this triangular prism, you have five faces. Front is a base. Front is the cross section, which is ABC. So I'm just going to quickly note down all the faces. Front is the triangle ABC. Back is the triangle EFD, right? And then we have AB, FE, the rectangle. And then we have AEDC. And then the last the last face which is left is the bottom face, this BFDC, right? Okay, so what we need to take care of here is that the lines are to be aligned. Like for example, what I mean is that the length DC, DC is attached from the base and this rectangle, right? I'm talking about DC. So if we uh, find any line DC on the net, make sure we either connect it with the rectangle AEDC or the rectangle BFDC, right? All right. So when we talk about the net, there are two things that have been made already. One is this, right? And the other is this face, right? So these two are connected. We understand that if this is 7, this also is 7, which means the common line between the two is this 7, which is AE. Now this basically tells us AE, right? So we have identified that this is A and this is E. And now from A to C, from A to B, it has to be 3. And from A to C, it has to be 5, right? So from if this is A, then from A to B, it had to be 3, right? And then from A to the like C, it had to be 5 because of what's been given, right? So we just have to label the numbers, I mean the dimensions, and then we are good to go. This is 4, this also is 4, this is 3. I'm just trying to label everything so it's easier for you to see, right? Okay, and then um we have I think E at the bottom. Yeah, so this is also 3 and then this is 5. So we need to see what's E is, right. So E and F are 3 units away and E and D are 5 units away. So E and F are 3 units away and E and D are 5 units away. Now let's see if BF is same as 7. So yeah, BF is 7 and also CD should be 7, right? So CD is also 7. So we have verified our net up to here. Now once we know that, once we have labeled the things that is already made here. So now let me change the color so it's easier for you to see other things. Now we need to draw all these shapes. I mean all these other things. So ABFE is already made and AEDC is already made. Now let's talk about the triangle ABC, EFD, and the quadrilateral BFDC. Now we will see whichever is better for us to draw. So I was thinking if we would, because we know that AB and BC are perpendicular to each other, so we have to make sure that if we extended from B, because C is AB, if we are extending it, if you're making a triangle with AB as the baseline of the triangle, we need to make sure that C is right above B, and that too 4 units up, right? So 1, 2, 3, 4. This is going to be my point C. This is 4 centimeters, right? And this is going to be my, right? Okay, then moving on, this is also done. ABC is done. Okay, let's talk about EFD. So EFD is this triangle, the back one. We can right, I mean, extend it from, we can make it connecting FD, or we can make it connecting EF. Let's see what we have. I think we have EF, so it should be the same way because it's all identical. So this D and this D should match, because when you try to fold it back, this D uh, and this ED and this ED have to be of same length, otherwise they wouldn't, you know. These letters are just for you to understand that if D would come back to the original position in 3 dimension, then it would move right above, right around D. E. So FD have to be 4 centimeters away, and this will be 5, right? And then the last rectangle which is missing is BFDC. Now for BFDC, we can either connect it with FD or BF or DC or BC, right? So let's see what we can do. Um, if I try to connect it with BF, is there a possibility? Yes. So BF is a line and it also has space. So let's do 7 by 4. So 7 is already here, and then this has to be 4. So 1, 2, 3, 4. And it will be C again, because it has to meet with when you try to fold it, this line and this line will be like joined together. So if this is 4 units away from B, the C is, if the C is 4 units away from the C, then this C also has to be 4 centimeters away from B, otherwise it wouldn't, these two lines wouldn't meet, right? So this point again, it has to be the same as this point D, right? Otherwise this DF here and this DF would not coincide. Let's, I think we are done with the net. Part E, calculate the surface area for the prism. So let's check it from the net only. Now there is these 1, 2, 3, 4, 5. So for any surface area problem, what I tell my students is to not memorize the formula for the whole shape. You just calculate the surface area for the each individual shape that is involved in the 3D shape, and then you can quickly, and then you can find out the areas for each individual shape, and then you add them up. So you get the total surface area of the this prism. So for shape number 1, it's 4 by 7, so it's 28. For shape number 2, it's a triangle ABC, so 1 times 2, and because these are two triangles, 1/2 of 4 times 3, right? So it's the same thing. And then we have rectangle 3, which is 21, and then we have rectangle 4, which is 35. 5 times 7 is 35, right? 96 centimeters square is the answer. Let's check it from the marking scheme. Um, correct net drawn. Okay, 96, yeah. Okay, so 96, right. Question number 6. Abjit cycles from his home to the swimming pool. The travel graph is here. Okay, then this is cinema. This is the shop. And this is the swimming pool, and this is his home. Part A, write down where Abjit stops on his journey to the swimming pool. So when he left his home and on his journey to the swimming pool, he passed through the cinema. This is where the cinema is. And he did not take a stop over this at the cinema. This is not a straight line from his home to the shop. It means that when he reached at the cinema, he kind of changed his speed, right? He kept going, but at a different speed until he reached the shop. And then at the shop, he waited for a while, which is about 5 minutes here, right? So now the the answer to this question is write down where Abjit stops on his journey. So he stopped at the shop basically. He did not stop at cinema, but he just changed his speed. Part B. Abjeet is cycling fastest between the shop and the swimming pool. Explain how you know this from looking at the graph. Okay, now we can see this. It's because of the gradient. Gradient actually tells you how steep our line is. So gradient, you can say that gradient because it's steeper, because the line is steeper. Uh, okay, so yeah, shop and steepest. Okay. Part C. Abjeet cycles at 20 kilometers per hour from his home to cinema. This journey takes 12 minutes. So the speed is 20 kilometers per hour and the time is 12 minutes. Right. We need to show that the distance is 4 kilometers. Now, this is the answer that's already given in the question. So, we cannot use this answer, but we have to reach to this answer. So, remember when we are talking about the formula for speed, it is distance upon time, but we need to make sure that distance and time must be with the unit that the speed has. Like, for example, speed is kilometers per hour. That means the distance should be in kilometers and the time should be in hours. Right, so speed is 20 kilometer per hour. If I'm using the same 20 kilometer per hour, that means the distance I will get will be in kilometers if my time is in hours. So 12 minutes basically is 12 divided by 60 hours, right? So this will go there to multiply. So S is equal to 20 times 12 over 60. So this is 3 and then this is 4. So my distance is 4 kilometer shown. Part 2, complete the scale on the vertical axis of the grid by showing at least two other values. All right. So home to cinema is 4 kilometers. This is home and this is cinema. From here to here, it's 4 kilometer. Let me see how many boxes does it have. 1, 2, 3, 4, 5, 6, 7, 8. So that means 8 kilometers, sorry, 8 boxes represent 4 kilometers, which means the next thing, if this is 4, then the next thing would be 8, and that too after 8 boxes. 1, 2, 3, 4, 5, 6, 7, 8. So swimming pool is 8 kilometers away from his home. Right, so 2 points are enough. They're asking for 2 points. Part D, calculate the speed in kilometer per hour that Abjeet cycles from cinema to the shop. Cinema to the shop. So basically we need to calculate this speed over here. So first let's see how much distance has been covered. So for on the y-axis where we have distance in kilometers, we know that 8 boxes represent 4 kilometer, right? That means one box is a half kilometer, right? So here this point is going to give me 7. This is 7. So when we are talking about this line, this particular line, we need 2 points on the line to calculate the gradient. So let's do it by rise over run. So from this starting point, there is this is 4. So from 4 to 7, it's 3 units back up, and then he is traveling a horizontal distance of again positive. So from here to this time. So one block is 2 minutes, right? Because there are 5 boxes and 10 minutes. So one box is 2 units. So 2, 4, 6, 8, 10, 12, 14, and one half box, which is 15. Right? So basically it's 15 minutes. So this is in kilometers and this is in minutes. Right, we have to write our speed in kilometer per hour. So what we do is we don't need this 15 minutes, we need the time in uh, hours, right? So 3 kilometers divided by 15 out of 60, This is in hours. So this, when you solve this, you will get the speed in kilometer per hour. So 3 divided by 15 over 60 gives me 3 times 60 over 15. 3 fives are 15 and 5 twelves are 60. So it's 12 kilometer per hour. Right. Moving on, part E. When Abjeet arrives at the swimming pool, it's closed without stopping. At the swimming pool, he decides. At the swimming pool, he cycles home at a constant speed. It took them 24 minutes. All right. He did not wait at the swimming pool and he took 24 minutes to cycle home. So, which means he started from here. And so he takes 24 minutes. So 24 minutes, because we know that one box is 2 minutes. So 24 minutes is actually going to be 12 boxes. So starting from here, this is my starting point, and then I have to go for 12 boxes. So these are 3 and then 5, 8, 9, 10, 11, 12. So this is the point where, I mean, this is the time when he's going to reach. So I'm just going to try to make a straight line. This is roughly the line, my graph. Calculate the average speed in kilometer per hour for the whole journey. So the formula for average speed is total distance upon total time taken. So total distance is 8 and 8, 16, because going 8 kilometers and then coming back 8 kilometers. So it's 16 kilometers. And then from starting 10 to ending the journey at one box before 11, that means 2 minutes. So it's basically 58 minutes, right? So distance is 16 kilometer and the time is 58 minutes. Remember, we need the speed in kilometer per hour, so we don't want this 58 to be in minutes. We want this to be in hours. So what we do here is divided by 60, so that my time will be in hours. So 16 divided by 58 over 60 is same as 16 multiplied by 60 over 58. Let me quickly use a calculator. 16 multiplied by 60 divided by 58 gives me 16.55. So 16.55, right? Okay. Part G, Abjeet's bicycle wheel has a radius of 29 centimeters. Calculate the circumference of the wheel. All right, so circumference is 2 pi r and the radius has been given 29, and we need to round it off to one decimal place. So it has to be 182.21. So one decimal place is 182.2. Yeah, okay. Part 2, calculate the number of complete turns the wheel makes when traveling 500 meters. All right. So we know that this is a rate question. At one complete turn, I'm writing short form. One complete turn is basically one circumference, which is, we know that 82.2. And this is in centimeters, right? And this is in 500 meters. It basically asks you that if it takes 182.2 centimeters for one complete turn, how many complete turns, which means we don't know the number of complete turns, will it make in 500 meters? So 500 meters is basically 50,000 centimeters, right? And then simply cross multiplying 1 times 50,000 is 50,000 is equal to x times 182.2. So basically it's multiplying, it will divide on the. So 50,000 divided by 182.2 is basically 274.4, but because we're interested in the number of complete turns, we always need to run it off backwards. So it's 274 complete turns, and then 275th turn is yet to be completed. Burton City is a football team. Burton City has 1732 supporters who want to travel to the next game. The football club hires some buses. Each bus seat has 52 supporters. Okay, so this is again great because the more supporters you uh, plan them to take, I mean to take them, if you plan to take more supporters to the game, you will have to have more buses, right? So it's direct proportion case, remember cross multiplication. So one bus has seats for 52 supporters, right? So the number of buses you need to calculate, so it's x because we don't know the number of buses, and the number of supporters we have are 1732, again cross multiplication. So 1732 multiplied by 1 is equal to x times 52, and x will give us the value of 1732 divided by 52. So it's 33.3. Okay, now we need to see that you cannot have 33.31 number of buses. So this is the case where you have to round it off forward because 33 buses are full of supporters, but you will still need to hire another bus for the remaining number of people. So I think the answer should be 34. Okay. See, it's not always necessary that you round it off forward or backward. If the rules, if it's just a random number, you can follow the rounding off rules. But if it's not just a random number, if it like if it's something from your daily life and it requires you to round off to a certain, uh, like always backwards or always forward, because previously in previous questions we saw that rounding off backwards was the only thing to do. Now in this question we have to round off forward whatever the number is, even if the first decimal place was 3, you still have to round it off forward. Okay, so the cost of the buses will be shared equally amongst these supporters. Each bus cost, okay, so again rate, so one bus costs us $198 to hire. Okay, and then there is the number of people that is to be shared. So first we need to know that there are 34 buses there that they're going to hire. So 34 times 198 will give us the total cost. So 34 divided multiplied by 198 is going to is the this is in number, this is in dollars, right? This is the dollar that that's going to be the cost for all the buses that will be hired for all these 1732 supporters. Now we need to see what is per head. So we divided into 1732 supporters, so 6732 divided by 1732 will give us 3.886. 3.886 correct to the nearest 10 cents. So let's say 3.90 should be for because this is first 10 cent and this is second 10 cent. So because this is in this is greater than 4, so we need to round it off forward the previous one. So 88 and then goes to 90. Right. Part B, Adam and Mabel are two supporters. The scale drawing shows the positions of Adam's home A and Mabel's home. Okay, so this is Adam and Mabel's home. Fine. The scale is 1 centimeter represents 500 meters. Scale, okay. Work out the distance. So basically what you need to do, I don't really see how this can be done without a ruler because I don't have a ruler right now on this. What you need to do is you first have to measure the distance between A and M and then convert. Like for example, the distance from A to M is, I'm just giving out a wild guess. Let's say it's 10 centimeters, right? So what you need to do is, this is the scale, right? The scale says that it's 1 centimeter is 500 meters. Now this is map and this is actual. So because you have measured 10 centimeter, this is just a guess because I don't have a ruler here right now, but I'll still explain you how this is done. So because this 10 is on the map, you write it under the map and the actual is missing. So multiply, you don't have to do the unit conversion because 1 centimeter is not actually 500 meters. It's basically 1 centimeter is representing 500 meters. So it's okay. The units won't matter. The units will matter here, these two, right? So 1 times x is x only, and 500 times 10 is 5000. So basically it's 5000 meters. Because if we have to write it down in kilometers, so I'm just assuming it to be 10, right? It cannot be actually 10, but I'm just giving you an example. So in kilometers, we know that there are 1,000 meters in 1 kilometer. So this, my answer is 5 kilometers. Now, definitely, it doesn't have to match it with the answer scheme. Let's check the marking scheme. It says 3.9. Okay, so because yeah, I told you I wasn't really accurate because of I did not have a ruler, right? And also because the thing is that even if I had a ruler, even if I had used a ruler, it depends on the zooming out. I mean, if I zoom this much, my measurement would change. If I zoom it this much, my measurement would change. So it's better if we do it on paper. So printed things are always good in this case. So part 2 says Burton City's football ground is on a bearing of 105 from A and on a bearing of 68 degrees from M. All right. 105 degrees from A, that means from the north. This it has to be 105 degrees from north. Okay, so what we need to do is we need to put up our protractor over here like this, the 0 in the center, and then this is 90 degrees, and then 105 should be somewhere around here. Let's make a rough line connecting A and the 105 point, removing everything extra. Roughly this is 105 degrees. So the ground could be anywhere on the line, and then reading the second thing, 68 degrees from M. So 68 degrees, like from this is M and the north is here. So what we need to do is we are going to set up our compass on M like this, that this is 0, and then check it from here, 68 degrees. So if this is 90, 68 degrees should be somewhere around here. So I'm just going to roughly mark this, removing everything extra. And then we are going to connect these, and this is the point where the uh, line could be, right? The football ground, right? Mark the position. So yeah, I think we should remove this. It's just still here. So indicated in the correct position, right? Okay, so for that, this you'll have to trust me on that. Right. See, teams are given points for winning on drawing games. A win is given W points and a draw is given D points. No points are given if when the team loses. All right. Burton City has 24 points after winning 2 games and drawing 5 games. Complete the. All right. So 2 games are won, right? So 2 times W, and 5 games have been drawn. So 5 times D. This together is 24 points, right? Let's see. 24 it is. Fine. Part 2. Now, I don't know how to pronounce this. Southern Rovers is another football team. Southern Rovers have 29 points after winning 3 games and drawing 4 games. That means 3W plus 4D is equal to their total points, which is 9. Solve the two equations to find the number of points for a win. Okay, so this is simultaneous equations. 2W plus 5D is equal to 24, and 3W plus 4D is equal to 29. I'm going to use I'm going to use the elimination method. So I'm going to multiply the first equation by -3, and I'm going to multiply the second equation by +2. Let me rewrite the equations. So -6W minus 15D equals -72. And then the second equation is 6W plus 8D equals 58. So adding the two equations gives me results me to eliminate the W from the list. And -15 plus 8 is -7D equals 58 minus 72 is negative 14. So dividing both sides by negative 7 gives me D is 2. So that means 2 are the points. When you draw a match, you get 2 points. Okay. So substituting in any of the two equations. So let's choose equation number 1. So 2W plus 5 times D, which is 2, equals 24. 2W plus 10 equals 24, subtracting 10 on both sides. So 2W is 14 and then W is 7, which means when you win a game, you get 7 points. Let's check it. 29 from the previous and 7 too, right? Next. Another team, Cranbrook United, has played 12 games. It has won 4, drawn 5, and lost 3. So you have to calculate for the points. So uh, 4 games it has won. So 4 times 7, because it has 7 points for one winning, and then drawn 5, so 5 times 2, and then lost 3. So remember, we the question said that there are no points if you lose a game. So no points are given, right? So 0. So 4 sevens are 28 plus 10 more points, and then 0 points for losing. So it's 38 points. Yeah, okay. Question 8. Complete part A and part B using a straight edge and compasses only. Construct the locus of the points that are equidistant from the line. Okay, so for equidistant points, so the set of points or the locus of points that are equidistant from 2 points are defined as the points lying on the perpendicular bisector of those 2 points. So first we need to connect X and Y. And then we need to make a perpendicular bisector on X and Y. So we need to open up our compass for more than half of the distance of X and Y. And the reason we do this is when you open up your compass for half of the distance, exactly half of the distance, what you do is when you make an arc, your arcs are not going to intersect. Like for perpendicular bisector, you need to open up your compass of more than half, put it on X, make an arc on the top of the line, make an arc on the top of the line, make an arc on the bottom of the line, and then use the same radius to put the needle on the Y, make exactly 2 arcs the same way, and then try to connect them, right? I like to connect them with a dotted line, so you can do whatever you like. So this is the perpendicular bisector on X and Y, and by the property of congruent triangles, if any point on this line will be equidistant from X and Y. For example, if you take this point, this will be equidistant from X and Y. That means if you take this point as P, for example, the distance between PX and PY will always be same, because this point has to be the midpoint because it's perpendicular bisector by the definition, and also perpendicular. So by the definition of congruent triangles, px and py will be equal, right? So if you take any point on this perpendicular bisector, it will still be the same. So you don't have to basically prove that uh, by drawing this point P. I think the perpendicular bisector thing should be enough for it. Correct, perpendicular bisector drawn with 2 pairs of arcs, right? Part B1, construct the locus of points that are equidistant from the line AB and AC. So when we're talking about the line AB and AC, we are talking about their angular distance between to them. So we have to divide them equally, which means we need angular bisector, right? So we need to bisect the angle A, which is between AB and AC. So for angular bisector, we need to put our compass needle on A with any radius, make an arc here and here, and you can change the radius. You can keep this radius as it is. Put the needle here on the new arc, new intersection point, make an arc here, put the needle here, make an arc here, and then connect. Because this is not that accurate, I'm just telling you how you would do it, right? Please make sure you're accurate with this. So this is angular bisector. Okay. Part 2, shade the region inside the triangle which is closer to AB than to C. All right. Closer to AB is this section, right? And closer to AC is this section. So we are interested in shading the section which is closer to AB. So because AB is this line, therefore this side of the angle bisector is all the points lying in this side of the angle bisector will be closer to the line AB. So we have marked it, correct region shaded, dependent on the line. Okay. So yeah, we're good. And then part C, complete this part using a ruler and compasses only. Construct the locus of points that are 4 centimeter away from the line MN. Okay, so 4 centimeter. Now there could be infinite many points, infinite many yeah, points which are away from the line, 4 centimeter away from the line. I mean, this point could also be 4 centimeter away from the line by telling you that this point is exactly 4 centimeter, which means it's perpendicular distance I'm talking about, right? So this point could be another line which is 4 centimeter away from this. There's many. So how would you do this? You will have to create a line perpendicular to MN, right? You can do this by using a set square, right? um, Make a line which is exactly 4 centimeters away. All right, and that's how you do it. You can use set square if you want. You can use a pair of compasses or whatever. So what you need to do is that you basically have to draw a line equal to the length of the line MN, such that the distance between these two lines is 4 centimeter. Okay, how will you do it practically? I don't have these things with me here, but at least I can tell you the how this is done. So first, what you need to do is pick up 2 points on the line MN. So let's take M and N only. So let me draw a 90-degree here. So this is roughly 90 degrees. This is 90 degrees, right? And again, I want my another 90 degrees because I want the perpendicular. I want to see the perpendicular distance, right? So this is 90 degrees. And then what we need to do is we need to connect these with basically this is 4 centimeters away, which means we need to make a rectangle. Now this is 4 centimeters. This is 4 centimeters. It has to be 4 centimeters away, right? So you open up your compass of 4 centimeters and make an arc. So let's say that this is 4 centimeters. Okay, put your needle on M and make another arc of 4 centimeters and then connect these two. So basically we've made a rectangle, right? Because other than rectangle, if you make a trapezium, so this point will not be away from perpendicularly from 4 centimeters away from the line MN, because the line this line segment MN stops at N, right? So any point other than this would not be acceptable. Correct loci drawn. All right. B1 for 4 centimeters are drawn. Centers M and N, fine. Two straight lines drawn parallel to M and N, and 4 centimeter from M and N on each side, fine. Okay, fine. Fine, that's good. Question 9, complete the table of values for this. So let me use my calculator and show you two ways on how to get all these values for x without making so many efforts for every time substituting in manually. So method number 1 is basic substitution, like we already know that you, instead of x, you put the values you're interested in, like -1, 1, 2, 3, 4, 5, all the values which are missing. So you can use it by regular substitution, that -1 squared minus 3 times -1, and then -1 again for the values for the value of y when x is -1. This is basic method, right? Another smart method of substitution is that if you see all these letters x, y, z, like all these letters here, they're in red, x, y, m, a, b, c, all these letters, we are going to use them smartly. So alpha x I'm using, right? Because it's in red, so I'm going to use my alpha key to unlock it. And then I'm going to use my the CALC button over here, which allows me to set value on my x. So right now I want my value of x to be -1 because that's what we are interested in right now. So -1, and then I'm going to press my equals to sign, and that's where it will tell me that the value of x is fixed uh, I mean in this case to be -1. And then I'm going to write the function in terms of x only, again alpha x squared. I'm going to type everything. We don't have to worry about um, substituting the values of x all the time. We can simply type the function and press equals to. We will get the value, which is 3. Now this means that because we saved the value of x to be -1, this function basically means that this function will give us the value of 3 when x was -1, right? Okay, so similarly you can change it, change the value of x. Now the next value I want is again calc button. The next value I want it to be +1, right? So I'll press 1 equals to. Now it saved it. Now I don't have to retype it. I just have to use this arrow key button to do the last function I did. Remember, this will only work if you do not press the on button and only work with AC buttons. So equals to will give you -3. That means when x was 1, y has to be -3, right? So this is one way of doing this. Another efficient method, and that's the method I prefer and I use, is by using table method. Now for that we need to go to this mode button and see this table on the key 7. I'm going to press 7 for the table, and this function of x basically means y. I'm going to input my function of this x squared minus 3x minus 1 here. So doing the same method, x squared minus 3x minus 1. Okay, so my calculator has this function of asking me another function if I want to input. So I'm not interested in another function. There's only one function I'm interested in. So I'll let it go. Press equals to, it will let it go. Now start button, I want my function to start from -2 because that's where my x is starting from, and then I'm going to end it by 5. It's by default it's 5. And step 1 means it has common difference of 1. Like from -2, the next number has to be one step away, which is -1, and then again one step, so it's 0, right? So you can change your steps accordingly, and then steps are done. Fine. It drew me a table. Like on -2, if we can see, when x was -2, f of x, which means y has to be 9. So we can verify it from here that if x is -2, y is 9. So if x is -1, y has to be 3, right? So we can check it from here. Then x is -1, y is 3, and then we can go down with the arrow key. 0 is -1, 1 is -3, 2 is again -3, and then 3 is -1, and then 3, and then 9. You will see that it's always symmetric, right? Okay, so the table is complete, and then these two numbers are really important. I'll show you how these will, you will need more numbers in between them. All right, so for B, we need to draw the graph. I'm just going to zoom it out a bit. Right, so -2 and 9. So the value of x is -2 and the value of y is 9. So my point is here. The next value I want is -x is the -1 and y is +3. This is my point. And then 0 and -1, this is my point. 1 and -3 has to be here. 2 also has a -3. And then 3, -1. 4, 3. And 5, 9. Now I'm going to draw the graph, connect the point with a smooth curve. Okay, so now the reason that I have not connected these two last points these 2 points, the reason is that if I try to connect them, it will go like this straight, which is not really the case, right? So when you have to draw this curve, we need to see that we the quadratic curves always have one extreme point that is either a maximum or a minimum. So in this case, it's clearly visible that it's going to have one minimum point, right? So it cannot have multiple minimum points. Like this -3 looks like it's a minimum point, and again a -3 at 2. It also has to be a minimum point in this case, right? Looks like, but it's not exactly the case. The perfect case is that we need to see right we need to locate a point that is right in middle of 1 and 2 to locate the midpoint, because this is the point where the graph is going to be symmetric. This is the line of symmetry, right? So you will see that all the points on the right side of this line have to be exactly symmetric to the left side, right? So this line on, connecting these two looking like extreme points is not the right thing to do. So what we are going to do is, while plotting, we don't have to do it in the table actually for part A, but only for plotting for part B, right? So for plotting of part B, we have to see where x is 1.5. So we need to calculate the value of y where x is 1.5, right? So 1.5 squared minus 3 times 1.5 minus 1 gives me negative 3.25. So this is roughly where it's going to be negative 3.25. I'm going to connect it with a smooth curve. Write down the coordinates of the lowest point. So this is the lowest point on my graph, which we just calculated. When x is 1.5, the value of y has to be negative 3.25. And then on the grid, draw the line of symmetry already drawn. I just drew it to explain you. So this is the line of symmetry. And in part 2, write down the equation of the line of symmetry. So it has to be x is equal to 1.5. And I believe that's the last question on this paper. Let's quickly check the answers. 1.5 and k, where k is between 3.5 and negative 3. So ours is 3.5 negative 3.25, so it's good. And then the ruled line, x is equal to 1.5, x is equal to, okay, all good. So I think that's the last thing on the paper. If you like my video, share it with your friends and spread the knowledge. Keep watching for more videos.